Okay, so today I'm going to present you the LinkSmart middleware platform, providing the overview, the introduction of the main concepts and the ideas behind them. It will happen in the following way. I'll start in the introduction, provide you the motivation, the problems which LinkSmart is trying to address, and then I go through the main subprojects, the pillars on which LinkSmart is built. So let me just start with the motivation. The Internet of Things is here. It's going to stay. More and more devices are being connected. The predictions say the numbers like 50 billion of devices till 2020. The other predictions say that 80% of those devices will be the systems which are actually already deployed, which are already there. They're not Internet connected yet, but they are going to. And all of these devices are different. They speak different protocols. There are consumer electronic devices. There are industry devices. And the applications that work with the data provided by those devices, applications that interact with those devices, they are also different. We have the desktop applications, we have web applications, mobile applications, different form factors, smartphones, tablets. Now we get the wearables. And all of this heterogeneity, so to say, is both in the devices, the protocols, and in the applications. Forward. So what we have is the distributed applications, the applications which are not running on a single machine anymore, the applications which span in the network, they span over the networks. They bring the complexities of the distributed systems. More specifically, they require service discovery. They require communication beyond the single private networks. And they bring a lot of complexity with managing the metadata of the IoT devices, services, managing the sensor data, processing it, and so on. So the LinkSmart middleware platform aims at alleviating the burden for the application developers trying to make the development of such IoT applications simpler. Its main subprojects which constitute the LinkSmart middleware is the LocalConnect, which focuses on the device integration and service discovery in private networks. The next one is the GlobalConnect, which extends the LocalConnect environments to global networks. It focuses on the service discovery in this global network and providing the tunneling of service requests, which I will get to, of course. And the last but not least is the LinkSmart services, which provides the middleware services that are the building blocks for the applications when it comes to building IoT systems and platforms that require sensor data processing and management of the metadata. So I'm going to start with the LocalConnect and then go over the other projects. The LocalConnect, as I mentioned, focuses on the private IP networks, on integrating IoT devices, which you can see at the bottom, with the device connector, the integration components, which I'll just explain on the next slides. Its goal is to enable the applications and services, which you can see here, to communicate with these devices. And in addition to that, the LocalConnect provides several services as the infrastructure for those applications and services, which include the resource catalog, the service catalog, which I also briefly explain in the next slides. So the first and the most essential task when building IoT application is the integration of the IoT devices. So on the left-hand side, we get the IoT devices, which speak different protocols. They are low-level protocols. In the industry, we see things like Modbus, bare Ethernet. In the consumer electronics, there are new protocols which are popping up in the recent years. And on the right-hand side, we have the applications which talk higher-level protocols like HTTP, MQTT, WebSockets, and so on. So with LinkSmart, we bridge the gap between the IoT devices and applications, allowing the applications to get access to the resources of the IoT devices by integration components, which we call the device connectors. Now, the device connectors are device or system and protocol specific. And they are integrating different kinds of devices. So on the one hand, we have the consumer IoT devices, which I already mentioned, with their own set of protocols. Then we have the industrial Internet of Things devices with their own protocols and their own kinds of devices like PLCs and wireless sensor networks. So the device connectors abstract different kinds of devices, both consumer electronics and industrial IoT devices, using the device and resource model. The device and resource model is rather basic. There are two kinds of entities. There are devices which are considered as the hosts of the resources, and the resources are modeled based on the Web of Things idea, where every resource has a state, and the state can be either obtained or it can be manipulated. So you can think about it as a sensor node, which has several sensors and an actuator on it, say a temperature sensor, barometer sensor, and the power switch. So the sensor node itself will be a device, and the individual sensors and the actuator will be the resources. So you can update the value of a temperature sensor, or you can change the state of the switch. So the device connectors are the ones which are operating with these abstractions. They are actually the components that create this abstraction and populate it in the network. The device connector itself is not a single software component. It is a specification with functional requirements which need to be implemented by the device connectors. And these functional requirements basically include three main parts. The first one is providing this modeling abstraction that I just described and populating this information in the resource catalog, which is the LinkSmart middleware service. The second one is the actual protocol translation from the device-specific protocols to the application higher-level protocol. And the last one is access to the actual resources of the devices using the protocol translation, so that the application can get access to the resources, modify the state, and obtain the state. There are several implementations of the device connectors. Some of them are more generic. The other are very system-specific, and we're working on building more of them. The device gateway is one of the generic device connectors, which is intended to be used for integration of DIY electronics and rapid prototyping on the platforms like Raspberry Pi and a handful of sensors, which talking GPIO, SPI, I2C, and so on. So using the device gateway, you can quickly integrate those devices and you can make them available in the network so that you can start building your application, accessing the data from them instead of hacking together the way to expose it over WebSockets and so on. The OPC device connector is a device connector which implements the OPC UA protocol and allows to connect different industrial systems which are using this protocol. So the integration of the devices with LinkSmart LocalConnect boils down to basically 2 points. The first one is you need to take an existing device connector or develop a new one and deploy it in the network. And in addition to that, you need to deploy the LinkSmart LocalConnect services so that the information from the device connector is populated in the resource catalog, and the resource catalog is registered in the service catalog, which is then used by the applications, by the clients. So the clients discover the resource catalog, and I get to this on the next slides. So once they have a handful of the resource catalog API, they can query it for the information on specific devices or resources that they are looking for. And based on this, the resource catalog provides them information about the endpoints, which are the device connector API exposing the actual device and resources behind them. It can be HTTP URL, it can be MQTT topic and the broker address where an application can get the sensor data stream. And it also provides information about the representation, which means the payload format in which the devices and resources are sending the data or accepting the state which you want to modify, which means that the LinkSmart is basically payload agnostic. You can use whatever format you like, but of course there has to be an agreement between the device connector and the applications. So once the client gets this information from the resource catalog, it basically has everything to directly query the specific endpoint from the device connector. whether it is a HTTP request or whether it is a subscription to the MQTT broker. So the second part of the LocalConnect is service discovery. And there are two kinds of service discovery mechanisms that we have in LocalConnect. The first one is the zero-conf networking, which is basically bootstrapping a client application without knowing anything about the network infrastructure. And with zero-conf networking and DNSSD as its implementation, the applications are able to discover the service catalog. And the service catalog is a simple registry of services with a RESTful API. So once the application discovers the service catalog, they query for other middleware services or even application services. So the service catalog, as I mentioned, is a registry. It uses active registrations, which means that it's a soft state system where services are assigned a TTL value, and if they are not, the registrations are not updated within a specific amount of time, those registrations expire. So if the service goes down, then it disappears from the catalog, obviously. The service catalog also provides automatic tunneling of individual services in the GlobalConnect network, which is optional and configured in the service registration information. And this is basically where I'm going to on the next slide. So now that we have an infrastructure in a private IP network where I can build the application, we can deploy application services, we can connect the IoT devices, we can discover the services, we can discover the devices, can communicate with them. The next step or the next use case are the applications which require communication beyond the scope of a single private network. For example, smart city applications or smart city platforms. So for those applications, we have the GlobalConnect. And as you can see on this example, we have 4 LocalConnect environments which are connected together in the GlobalConnect overlay network. And it provides 3 basic functionalities. The first one is the overlay network, which is the task of building a virtual network on top of the internet to connect individual LocalConnect environments. The second one is the service discovery, which is similar to what we do in the LocalConnect with discovering services on the private network. With GlobalConnect, we discover services which are supposed to be discoverable outside of the LocalConnect environment. And I'll give an example on the next slide about this. And then finally, service tunneling is once the application discovers the service, the tunneling makes them capable of actually communicating with those services. So the overlay network, the idea of the overlay network, is that it builds a virtual network on top of the internet, which is called the overlay. And it connects the LocalConnect environments in a single global network with virtual addresses and so on. So what's specific to LinkSmart is that we use interchangeable backbones. The backbones is what we call the actual mechanisms, the bottom layer for creating the overlay network. They can use different architectures. They can be centralized. They can be decentralized, like peer-to-peer. They can be hybrid. The service discovery is the way that the applications discover services from different LocalConnect environments. So in this example, we have the LocalConnect. We have a LocalConnect B environment where there is a service, and we have a LocalConnect A environment where we have the application. So every one of them, like the service B, is deployed in LocalConnect B. So local applications to LocalConnect B can communicate with it using its IP network, discover it using the service catalog. And now we have an application in LocalConnect A environment that wants to communicate with the service. So using the GlobalConnect discovery, using the LocalConnect discovery first, we register it in the service catalog, which is the normal procedure so that the applications in local network can discover it. Now that we want to expose it, we configure this registration information in there, setting the flag that this service needs to be exposed in the GlobalConnect. So once this is done, the border gateway of the LocalConnect B network picks this information from the service catalog. This information is traversed in the overlay network. It arrives at the border gateway A in the LocalConnect A environment. And there, the border gateway puts in the local service catalog of the network A. And then the application is able to discover it. So now that the application has information about the service, it wants to actually make the request. Well, making the request is not that easy, of course, because there are firewalls, there are NATs between LocalConnect A environment and LocalConnect B environment. And this is where the service tunneling comes into place. So the service tunneling in GlobalConnect is basically providing access to remote services in local environment. It is actually transparent to both application and the service because the application gets the endpoint of the actual service tunneled in its local network. So it doesn't need additional configuration. It can be aware that it communicates with the tunneled service, but it doesn't have to be. And for the service, it's the same. The border gateway in the LocalConnect B environment, in this case, acts on behalf of the client, making the requests as if it was a local application. There are different protocols that are tunneled in this way. We call them the backbone protocols. So at the moment, we tunnel HTTP services, and we're working on tunneling MQTT as well, which basically provides you with a pub/sub service which spans beyond the single local network. Yes, so now that we have the LocalConnect, where we integrate the devices, integrate the applications, and we have the GlobalConnect, which allows us to connect multiple LocalConnect environments and build applications which scale beyond a single network. We have the infrastructure to implement IoT applications. And this is very nice, but there is still a lot of work that has to be done. And this work is usually application-specific. There is business logic, there is analytics, which are application-specific. But, well, we believe, and our experience says, that there are some tasks which are shared by applications. And this is why we provide the middleware services. So one kind of these services are the services which are working with sensor data processing, including the sensor data fusion and sensor data aggregation. Then we want to store the historical data, because most applications actually need to give some to persist the data, to visualize it in some way, and to do analytics as well. They also need historical data store. So this is where we have service providing this persistence of the sensor data, and also allowing the user to define the retention policies so that the user can decide which data needs to be stored for how long, and which data needs to be discarded. Then there is the management of the metadata. So I mentioned the resource catalog and service catalog services, which the first one provides basic metadata information about the deployed IoT devices. The second one provides the information about the services. But then if we want to build more sophisticated systems, we want to build more sophisticated applications that need a higher level of abstraction, that want to use, say, semantic web technologies to annotate the data so that it is discoverable, so that they can do more complex reasoning and so on. We need additional services that provide this kind of metadata management. And this is also something we're working on. And there are other services as well, which we hope to identify in the future and complement the library of the services for LinkSmart. To get more information, you can start by going to the linksmart.eu, the main project website. There are also the sub-projects that I mentioned. The most interesting ones are probably the LocalConnect and GlobalConnect. We keep all the documentation in the wiki and trying to update it. If you have any contributions on this, any suggestions how we can improve it, we would be grateful to hear that. So on this, I'd like to thank you for listening and watching. And till next time.